Here's something that doesn't get said enough. Venus might not have always been a furnace. Some scientists think it could have been stable and wet for billions of years. Oceans, rainfall, maybe even a climate that wasn't so different from Earth's. And then, something happened. The planet flipped. Oceans boiled off. The air thickened into a suffocating soup of carbon dioxide. And all that was left was a world that today can melt a spacecraft in hours. And the problem is that we don't actually know when this disaster happened. Did Venus always lean toward being a hellscape, or did it only become one recently, maybe in the last billion years? If it really did stay Earth-like for that long, then Venus wasn't just a failed twin. It was a lost world, a planet that had everything going for it until it didn't. That's the mystery we're going to pull apart. Not the surface-level story you've heard before, but the deeper question. What chain of events turned Venus from a place that could have been alive into a planet that's now completely unforgiving? To understand what went wrong on Venus, you have to piece the story together like a crime scene. The planet didn't just wake up one day and decide to become the solar system's furnace. It was a chain of events, atmosphere, geology, and sunlight all feeding into each other, until Venus passed a point where nothing could stop the spiral. Start with the basics. Venus and Earth began with similar raw materials. Both planets formed approximately 4.5 billion years ago from the same disk of dust and gas around the Sun. Both ended up with rocky crusts, atmospheres, and probably oceans. Venus isn't much closer to the Sun than we are, orbiting at about 0.72 astronomical units, 108 million kilometers, compared to Earth's 1 astronomical unit, 150 million kilometers, so in theory it should have been able to keep conditions mild. For a long time, it probably did. But the seeds of disaster were already in place. The first key factor was volcanism. Venus is covered in volcanic plains, and radar mapping shows that a huge portion of its surface has been resurfaced by lava flows within the last billion years. That means the planet went through episodes of extreme volcanic activity, releasing staggering amounts of carbon dioxide into the atmosphere. On Earth, volcanic gases eventually cycle back into rocks and oceans. Plate tectonics move the crust, rainfall washes gases out of the sky, and carbon gets buried. But Venus doesn't seem to have plate tectonics. Its crust is one giant stagnant lid, without the moving plates that recycle material. So when volcanoes pumped out gas, it just stayed there. Over millions of years, the atmosphere thickened with CO2, slowly turning into a suffocating blanket. As the atmosphere got denser, the greenhouse effect took over. Sunlight still reached the surface, but the heat it generated couldn't escape back into space. Instead, it was trapped by the carbon dioxide. The hotter the surface got, the more water evaporated into the air. And here's the critical feedback loop. Water vapor itself is a powerful greenhouse gas. So every extra bit of evaporation made Venus hotter, which caused even more evaporation. At some point, this cycle ran out of control. Venus crossed the line into a runaway greenhouse effect, where the planet heated itself faster than any natural system could cool it. That brings us to the second major piece of the puzzle, the loss of water. If Venus really had oceans in the past, and the isotope ratios in its atmosphere strongly suggest it did, those oceans didn't just sit there quietly while the planet heated up, they boiled. The surface turned into a global steam bath, with water vapor dominating the skies. High in the atmosphere, ultraviolet light from the sun broke those water molecules apart into hydrogen and oxygen. The hydrogen, being light, escaped into space, bleeding away piece by piece. The oxygen should have stayed behind, but Venus has almost none today, which means it must have reacted with surface rocks or been stripped by solar winds. To make things worse, Venus has what scientists call an electric wind, a stream of charged particles flowing from the upper atmosphere out into space. That wind is strong enough to drag ions, including the fragments of water molecules, away forever. Over time, the oceans simply vanished, leaving the planet bone dry. Meanwhile, the volcanic activity never stopped feeding the fire. Without plate tectonics to recycle gases, every eruption just added more fuel to the greenhouse blanket. Venus's crust may even go through catastrophic resurfacing events, where heat builds up underneath until the entire surface collapses and floods with new lava. Each time that happened, the atmosphere would have been loaded with fresh carbon dioxide and sulfur compounds, reinforcing the runaway conditions. Instead of stabilizing, the planet locked itself into an even hotter, denser state. The result is the Venus we see today, an atmosphere made of almost pure carbon dioxide, over 90 times thicker than Earth's. Clouds of sulfuric acid that reflect sunlight back into space, but trap heat below. Temperatures of 460 degrees Celsius. Hot enough to melt lead, with almost no variation between day and night, equator and poles. And a surface pressure so intense that any spacecraft we've sent has been crushed or fried within hours. So, what the hell happened to Venus? It was a perfect storm. Volcanoes filled the air with carbon dioxide. The lack of recycling systems meant nothing removed it. The greenhouse effect spiraled until it boiled the oceans. The loss of water stripped away the last chance of stability. And without water, without a carbon cycle, without protection, Venus tipped into a permanent greenhouse state that can't be undone. What makes this story even more unsettling is how close Venus once was to being stable. For billions of years, it may have been mild and even habitable. Oceans could have lasted long enough for life to get a foothold. Then, slowly at first and violently in the end, the balance shifted. A planet that had everything going for it became the most hostile place we know. Venus isn't just another world in our solar system. It's a warning. It shows that planetary habitability is fragile and that losing balance doesn't take much. If a planet so similar to Earth could collapse into fire and acid, it forces us to realize just how precarious our own balance is. It's a reminder that the balance we have here on Earth is worth protecting. And that's exactly what my friends at Planet Wild are working on. They're a community-based nature protection organization. Every month, their global community funds real projects that protect nature, from restoring ancient forests to rescuing wildlife. Think of it as crowdfunding for nature. They document all their projects in video reports that you can find right here on YouTube, so you can see what your contribution helped achieve. What I like is how direct it feels. You can see exactly where your money goes in their videos or on their app. You can follow the updates, and you can even get your name credited in their monthly project videos. It's clear, transparent, and honestly pretty motivating. Like in one of their recent projects, we could see how our contributions were used to fund chainsaw detectors and protect one of Europe's last ancient forests. I joined myself, and it genuinely feels like being part of something. It's thousands of people combining their efforts to make an impact none of us could manage alone. And the scale of that is what makes it powerful. One month it's forests, the next it's oceans, and every time you know your membership is part of making that happen. If you want to join too, check the link in the description. You can give whatever amount, big or small, that feels right to you. Every contribution goes straight into the next mission, and you'll actually see the results for yourself in less than 30 days. Here's a special gift. The first 100 people to sign up using my code FEXEL10 will get their first month paid for me. Just click the link in the description or scan the QR code. It's one of the rare chances where you can watch your support turn into something real, and there's no catch here. You can cancel anytime. Talking about Venus in theory is one thing, but nothing hits harder than seeing what it actually looks like. For centuries, the planet was nothing more than a dazzling light in the sky, a mysterious world hidden beneath a veil of clouds. Telescopes couldn't penetrate its thick atmosphere, so no one really knew whether it was covered in oceans, jungles, or deserts. When spacecraft finally arrived, the images they sent back revealed a truth that was harsher, stranger, and more unsettling than anyone had expected. The first real look came from the Soviet Venera landers. These machines were built with one goal: to survive the most hostile environment ever encountered by a probe. Most of them were destroyed quickly, but a few managed to function long enough to capture photographs of the surface. Those images remain some of the rarest in space exploration. The sky in them is not the familiar blue of Earth, but a suffocating orange, colored by the thick carbon dioxide atmosphere and layers of sulfuric acid clouds. The ground looks barren and cracked, with slabs of dark rock scattered like broken pavement. There are no rivers, no soil, nothing that hints at life or motion. It is a still, silent landscape, baked under crushing air pressure and relentless heat. Each photo feels like it was stolen from a place that wants no witnesses. Because cameras couldn't see through the clouds, scientists turned to radar. In the 1990s, NASA's Magellan spacecraft orbited Venus and mapped the entire planet, using radar signals to peer through the atmosphere. The mosaics it produced weren't photographs in the traditional sense, but they revealed the true nature of the surface. Instead of a static, ancient crust, Venus was covered in volcanic plains. Gigantic lava flows stretched for hundreds of kilometers. Mountains taller than any on Earth rose from the plains, and vast circular structures called coronae marked places where molten rock had pushed upward, warping the crust before collapsing inward, leaving behind the circular ring-like scars. These images told us that Venus is a planet shaped by fire, one that may have been resurfaced in catastrophic events that erased older features and replaced them with new oceans of lava. Other spacecraft focused on the atmosphere itself. In ultraviolet light, Venus looks completely different from the pale, uniform disk seen in visible light. Missions like Japan's Akatsuki have captured images of sweeping cloud bands racing around the planet. These clouds move so fast that the entire atmosphere circles Venus in just 4 Earth days, a phenomenon called superrotation. In those images, dark patches appear across the cloud tops, evidence of some unknown substance that absorbs ultraviolet light. To this day, no one knows exactly what it is. Some suggest unusual chemicals, while others wonder if it could be tied to exotic microbial life. Whatever the explanation, those dark streaks remind us that Venus still keeps secrets, even in places we can observe directly. Infrared instruments have gone further, peering through the atmosphere in narrow windows where it becomes transparent. These views have revealed hotspots glowing faintly from the surface, matching up with volcanic regions seen in radar maps. Some of these hotspots may be signs of active eruptions, suggesting Venus isn't just scarred by ancient volcanism, but could still be alive with fire today. If true, these images aren't just snapshots of a dead world, but evidence of a planet that's still changing beneath its suffocating sky. Even flybys have added to the picture. When NASA's Parker Solar Probe and ESA's Bepi Colombo spacecraft swung past Venus for gravity assists, they captured fresh images of the planet as a crescent against the blackness of space. From that distance, Venus looks calm, glowing, almost serene. It's a reminder of how deceiving appearances can be. From Earth, we see a bright star in the evening sky. Up close, the images show us a world that is anything but peaceful. Together, these images form a record of Venus's true nature. The orange skies and rocky slabs from the Venera landers show us the furnace-like surface. The radar maps from Magellan reveal the scars of volcanism and massive resurfacing. The ultraviolet views expose hurricane-like winds and mysterious dark streaks in the clouds. The infrared hotspots hint at ongoing activity, and the distant flybys remind us of its deceptive beauty. Seeing these images makes it impossible to think of Venus as just an abstract example of planetary science. They show us a real place, harsh and alien, yet close enough to feel uncomfortably familiar. Whenever Venus comes up in conversation, the idea of life usually feels impossible. After all, how could anything survive in a place that's hot enough to melt metal, where the air is toxic, the pressure is crushing, and the clouds rain acid? The surface, as we know it today, is absolutely hostile. No complex machine we've built has lasted more than a couple of hours down there, so the idea of life seems almost laughable. But that's only if we judge Venus by what it is now, not by what it may have been in the past. If Venus truly had oceans, as many studies suggest, then for a huge stretch of time it may have been stable enough for life to form. The ingredients were there: liquid water, volcanic activity to drive chemistry, and plenty of time. On Earth, life appeared relatively quickly once conditions were right, within a few 100 million years. If Venus had oceans for billions of years, it's hard not to wonder if something similar happened there. We'll never find fossilized shells or skeletons because the surface has been resurfaced and baked beyond recognition. But life doesn't have to be complex to matter. Even microbes, the simplest organisms, would change the way we see our place in the universe. If Venus once supported even a microbial biosphere, then life might be far more common than we think. That covers the past. The harder question is whether life could exist on Venus now. The surface is a death trap, But not every layer of the atmosphere is the same. About 50 to 60 kilometers above the ground, conditions shift dramatically. Temperatures there are much cooler, around levels closer to what we'd consider comfortable. The pressure is also similar to Earth's surface pressure. Sunlight is available and winds circulate material. In short, that region is the only place on Venus where anything remotely resembling habitability exists. That's why some scientists suggest the clouds of Venus might still host microbial life. This idea isn't new. Carl Sagan raised it in a seminal 1967 paper published in Nature. He suggested that Venus's upper atmosphere could harbor microbial life in the form of hardy airborne particles floating within the temperate cloud layers, where liquid water droplets might exist and shield organisms from the planet's scorching surface and intense radiation below. But it gained attention again in 2020, when a team of astronomers led by Jane Greaves, using ground-based observations from the James Clark Maxwell Telescope in Hawaii and the Atacama Large Millimeter/Submillimeter Array in Chile, claimed to detect phosphine in Venus's atmosphere. On Earth, phosphine is associated with biological activity. Microbes produce it in oxygen-poor environments. Finding it on Venus was shocking because there wasn't a clear chemical explanation for how it could form naturally in such large amounts. The headlines spoke of life, but science is cautious. Follow-up studies challenged the finding, with some arguing the signal was weaker than first reported or even an artifact of processing. The debate isn't settled, but the fact that it sparked global attention shows how seriously the possibility is taken. Even without phosphine, the idea remains intriguing. Could microbes survive in droplets of sulfuric acid high above the surface? For us, it sounds absurd, but life on Earth has already proven to be adaptable. We found bacteria thriving in boiling hot springs, in acidic lakes, and even inside nuclear reactors. Extremophiles, as they're called, show that life can make a living in places we once thought were impossible. If microbes can adapt here, maybe they could adapt there. Of course, the challenges are immense. The clouds are made mostly of sulfuric acid, which would dissolve most life forms we know. Water is scarce, and water is usually essential for life as we understand it. Still, as we understand it is the key phrase. Just because we can't imagine it doesn't mean nature couldn't have come up with a solution. Venus forces us to stretch our imagination beyond the comfort zone of Earth. What makes this discussion valuable is what it tells us about habitability in general. If life can exist, or once did exist, on Venus, then life doesn't need perfect Earth-like conditions. It can appear, survive, and maybe even persist in places that look hopeless from the outside. That possibility reshapes the way we search for life in the universe. Instead of only looking for worlds with oceans and blue skies, we might have to consider cloud decks, underground niches, or chemical environments that seem alien to us but are still viable to something else. In the end, the possibility of life on Venus isn't about proving that it's there. It's about expanding what we think is possible. Whether it happened billions of years ago in ancient oceans or whether it's still clinging to survival in the clouds, the mere chance forces us to take Venus seriously as more than just a dead world. It may be hostile, but it's also a reminder that life and habitability are not simple checklists. They are experiments carried out by planets, each with different outcomes. Venus could be the failed twin that never supported life at all. Or it could be the lost world that once had oceans full of microbes before it collapsed into fire. Or, and this is the wildest but still plausible scenario, it might still be home to organisms drifting above the inferno, hidden in the acid clouds where machines haven't yet searched closely enough. Until we go back and test it directly, we won't know. But even the possibility makes Venus one of the most fascinating places in the solar system. Not just because of what it became, but because of what it might still hide. For all the questions we've asked about Venus, the truth is, we don't have nearly enough answers. Part of the problem is that Venus has been neglected. Mars has been the favorite for decades, with rovers, orbiters, and landers studying every corner of it. Meanwhile, Venus has been sitting right next door, wrapped in clouds, waiting for attention. The last time NASA sent a dedicated mission, there was in the early 1990s with the Magellan spacecraft. Since then, Venus has been mostly studied from a distance or with brief flybys as spacecraft headed elsewhere. That gap in exploration is finally about to change. NASA has two major missions on the horizon, Veritas and Da Vinci. Veritas will orbit Venus, mapping its surface with radar far more advanced than Magellan's. Its goal is to figure out whether the planet is still geologically active. Are volcanoes erupting? Is the crust moving? Are there signs of change? Da Vinci, on the other hand, is designed to dive into the atmosphere itself. It'll drop a probe straight down, sampling the air as it falls, measuring gases, and taking images of the landscape on the way. If Da Vinci succeeds, it will give us the most detailed look at Venus's atmosphere ever recorded, and maybe even answer whether the planet once had oceans. Europe is also stepping in with the Envision mission, which will provide high-resolution radar mapping and study how the atmosphere and surface interact. Together, these missions will give us a complete picture: the surface, the atmosphere, and the history written in both. For the first time in decades, we'll actually have the tools to test whether Venus is volcanically active right now and whether its clouds hold unexpected chemistry. Why does this matter? Because without fresh data, we're left with speculation. We can run climate models, we can make guesses based on old measurements, but until we go back and look, the biggest questions stay open. Did Venus ever have oceans that lasted for billions of years? Did it collapse into a runaway greenhouse slowly? Or was it triggered by massive bursts of volcanism? Does anything unusual still happen in its clouds today? These are questions we can't answer from Earth. And there's more at stake than curiosity. By studying Venus directly, we learn about planetary evolution. We learn how atmospheres behave, how climates change, and what can tip a planet into disaster. That knowledge applies directly to Earth, especially as we study our own climate. Venus isn't just a cautionary tale from the past, it's an active laboratory, showing us processes that we need to understand if we want to grasp the long-term future of our own world. So the coming decades could finally give us the missing pieces of Venus's story. After years of being ignored, the planet is back in focus. Every new mission, every measurement, every image will bring us closer to solving the mystery of what the hell happened there. When you step back and look at the full story of Venus, it almost feels like a tragedy written across a planetary scale. Two worlds started with so much in common. But while Earth stabilized and nurtured life, Venus spiraled into chaos. Oceans boiled away, the air thickened into a suffocating blanket of carbon dioxide, and the surface became a landscape of fire and acid. The question we started with, what the hell happened to Venus, doesn't have a single neat answer. It was a combination of factors, each one feeding into the next. Volcanoes released gas with no system to recycle it. Carbon dioxide trapped heat until the planet overheated. Water vanished into space, removing the last chance for balance. The crust itself may have collapsed and rebuilt in catastrophic bursts, loading the atmosphere with even more greenhouse gases. In the end, Venus locked itself into a runaway greenhouse state, turning from a world that may once have been mild and even habitable into a permanent furnace. The images prove it. The haunting photos from the Venera landers show us the rocky surface under an orange sky. The radar maps from Magellan reveal plains of lava and the scars of violent geological activity. The ultraviolet views from Akatsuki capture the raging winds in the upper atmosphere, racing faster than the planet itself spins. And the faint glow of hotspots in infrared reminds us that Venus may still be active, still changing, still restless under the clouds. But maybe the most unsettling part isn't what we know, it's what we don't. Did Venus truly have oceans for billions of years? Did life ever spark in those waters, even if only at the microbial level? Could something, however strange, still cling to existence in the cooler cloud layers above the surface? The evidence is incomplete, and the answers remain out of reach. Yet the possibility is enough to make Venus one of the most compelling worlds we've ever studied. Studying Venus isn't just about curiosity, it's also about perspective. The planet reminds us that habitability is fragile. Earth feels stable, but that stability depends on balances that can shift. Venus shows us what happens when those balances collapse. And just a quick reminder, If you want to be part of Planet Wild's next mission, the link's right there in the description. Every membership helps protect nature, and you'll see the results in their monthly videos. Thank you for watching this video. Don't forget to subscribe and check out the video on your screen.